Find the area of the region between the curves f of x equals x cubed minus 2x squared plus x minus 1 and g of x equals negative x squared plus 3x minus 1. These are they're both given as functions of x. Let's see what we can do with this. Step 1, find the points of intersection. We do that by setting f of x equal to g of x. In other words, y sub 1 equals y sub 2, and solve for x. Okay, so replace f of x with x cubed minus 2x squared plus x minus 1 equals, replace g with negative x squared plus 3x minus 1. Now let's solve this second degree equation. We're going to get everything on one side. Oh, it's a third degree. Factor out the common factor x. Let's see, try to factor the second degree portion. Yes, we are able to factor. Now, we're going to set each of the factors equal to 0 and find the y partner. Now, to find the y partner, insert x equals 0 into either the f or g function. It doesn't matter which, because they have this point in common. They're going to give you the same solution for the y coordinate. So here we get the ordered pair 0, negative 1. For x equals 2, we plug that into the g function, and we get the ordered pair xy equals 2, 1. And then plug x equals negative 1 into the g function, and we get the ordered pair of intersection xy equals negative 1, negative 5. Okay, so here's our 3 points of intersection. Step 2, we're going to make a sine graph. The sine graph is going to tell us which function is higher and which function is lower on the interval of the x-axis that's busted up using these 3 points of intersection. So here's our f function, here's our g function, not the derivative. We're looking at the actual functions f and g. Now we're going to take the x-axis and we're going to bust it up using the x points of the intersection. First we have x equals negative 1, then x equals 2, 0, I'm sorry, that comes next, and then x equals 2. Okay, so let's fill in this table. We have to consider what happens for x values between negative 1 and 2. Let's take a sample x equals negative 1/2. That lives between negative 1 and 2. Evaluate f and g. We get f of negative 1/2 equals 3/8, but g of negative 1/2 equals negative 22/8. So what that means is it means that on the x interval from negative 1 to 0, we have g smaller and f greater. So the f function is the upper function, the g function is the lower function. Now let's choose a value of x between 0 and 2. And let's evaluate f and g. Let's choose x equals 1. That lives between 0 and 2. When we evaluate f, the y partner is negative 2. Evaluate g, the y partner is 1. So on the interval of x values between 0 and 2, the f function is the lower function, while the g function is the upper function. Now we know what to do with the integral. We know which one's higher on each interval. Okay, we're going to evaluate the integral now for step 3 for the areas between f of x and g of x. Okay, we're going to partition those areas up and make different integrals. There's really only 2 regions. There's the region from x equals negative 1 to 0 and the region from 0 to 2. So first let's consider the integral from x equals negative 1 to 0, the upper function f minus the lower function g dx, plus the integral from 0 to 2, x equals 0 to 2, of the upper function g in that region minus the lower function f in that region. Go ahead and plug in the functions for f and g. We get the integral from negative 1 to 0 of x cubed minus x squared minus 2x dx, plus the integral from 0 to 2 of negative x cubed plus x squared plus 2x dx. That's what we get when we do the differences, subtraction, and simplify. Okay, antiderivative is x to the 4th over 4 plus x cubed over 3 minus x squared evaluated from x equals negative 1 to 0 plus negative x to the 4th over 4 plus x cubed over 3 plus x squared from x equals 0 to 2. Let's go ahead and evaluate those those antiderivatives there. I'm going to pull out the LCD. You don't have to if you don't want to, but I'm pulling it out so I can work with whole numbers. 112 times 0 minus 0 minus 0 minus 3 plus 4 minus 12 plus, the other one is negative 96 plus 32 plus 24 minus 0 plus 0 plus 0. So that means when I distribute multiplication, I'm going to get 112 times 5 plus 32. So I'm going to have 37 in the numerator, 12 in the denominator. If I could, I would simplify by factoring and canceling, but I can't. Now let's draw a picture at the top. Look back up at the top here. Let's see what this thing looked like. It was actually a tough one to graph, so it was better to work without the graph. Sometimes it's just too difficult to graph, so you can just do the problem without even seeing it. Just use your imagination. Well, this is what it actually looks like. Here we have G graphed on the XY axis, and then we have, let's see, there's a squiggly thing which is our F function, and you see the X coordinates from negative 1 to 2. That's what we're interested in, negative 1 to 2, and the upper function changes from 0 to 1, I'm sorry, from negative 1 to 0, the upper function is the F function, while from 0 to 2, the upper function is actually the G function. So that's how we had to evaluate it very carefully. So it is possible to do these problems without even drawing the picture.